Good morning, everyone. Today, my team and I will be presenting you on Physics Chapter 13 about light. Our team members consist of me, Wong Jun, Victor,
and Rohan.
Yeah, okay, so about light. Light travels in a straight line, but changes direction whenever it travels from one material to another, or whenever it hits a shiny surface. So as you can see from the figure there, the flashlight, which is the source of the light, hits the mirror. Then it reflects off the mirror, and that's called the reflected light. Whenever a ray of light reflects off a mirror, there are two rays that are present: the incident ray and the reflected ray. And whenever the two rays are present, there are always two angles: the angle of incidence and the angle of reflection. Those two angles are always the same, as shown in figure 1. The image in the plane mirror. Images in the plane mirror are always inverted, so whenever you move your right hand, the image in the mirror will show that it's your left hand. Now, the properties of a virtual image is always the same size as the object, and the distance in front and behind the mirror is always the same. So if I'm maybe 30 cm or 50 cm away from the mirror, behind the mirror it will also be the same distance, and it will be also inverted like I showed you just now. And it's virtual, it doesn't exist. Refraction of light. When light travels from one material to another and bends, it's called refraction. As you can see in the picture, the light enters straight in, and whenever it hits the glass block, it bends up, and then after it exits, it goes back to the original line. And the ray of light travels in a straight line, but then, like I said earlier, whenever it enters a block of glass or hits something shiny, then it will bend. It changes direction because of the speed of light. Light travels fastest in vacuum, but almost the same in air, so there's not much of a difference. But it travels much slower in glass or water. When light travels faster, the angle is larger. In the figure, you can see that in the glass, the angle is 34.5 degrees, but then in water, the angle is 40.6 degrees. So from this, we can already see that whenever the light travels faster, like in air, then there's a bigger angle. But then when it travels slower, like in a solid, then there will be a smaller angle. Refractive index. Whenever there's a ray of light present from air to glass, it will slow down, and the refractive index allows you to calculate the angle of refraction with the formula shown on the screen. Now I'll pass my time to Rohan to explain more about total internal reflection.
Total internal reflection. When the angle of incidence is greater than a particular value known as the critical angle, the light is entirely reflected inside the glass. This is known as total internal reflection. In figure A, it is partially reflected because the angle of incidence is less than the critical angle, so some is reflected and some is refracted. In figure B, critical angle, the ray of incidence is the same as the critical angle, so the angle of refraction will be 90 degrees. In figure C, the angle of incidence is greater than the critical angle, so it is totally internally reflected and there is no refracted ray. For total internal refraction to happen, the ray of incidence must be greater than the critical angle. The critical angle depends on the material. Now I'm going to pass my mic to Victor. My time to Victor.
Alright, optical fibers. Telecommunications are made possible by the invention of fiber optics. Telephone messages, internet, and cable TV signals are passed along fine glass fibers, which are fiber optics. Inside a fiber, light travels by total internal reflection. Each time it bounces inside of the fiber, its angle of incidence is greater than the critical angle. The fiber and light can follow a curved path. For signals that travel long distance, glass with a very high purity is needed so it does not absorb the light. So for lenses, there are two types. First one is converging lenses. It's fatter in the middle than the edges. The second one is diverging lenses. It's thinner in the middle than the edges. The size of the image depends on how fat or thin is the lens. One of the many uses for lenses are for eyeglasses. The lenses of eyes fails to properly focus light, so lenses are used to correct them. Lenses work by refracting light. When a ray strikes the surface of the lens, it refracts towards the normal. Converging lens bends all the rays to meet that principal focus. So for magnifying glass, there are four features an image produces. First one is upright, second one is magnified, third one is it's further from the lens than the object, fourth one is virtual. Thank you for watching.
Thank you for watching. I hope you enjoyed our explanation and that is clear to you. And yeah, thank you for watching.